Okay, so we're still working with complex numbers. All of the same like concepts we just did in the review and everything. It's pretty much the same thing, except we're going to add imaginary numbers to it, which just changes how it looks. All right, so with an imaginary number, you have this I symbol. So like maybe 2I. This is an imaginary number. Have you guys seen this I before?
Yes.
And heard about imaginary numbers?
Algebra 2 trig.
Okay, this is good news to hear. Most of you. London? Okay. So let me ask you this. What's the square root of 4?
2.
What's the square root of negative 4?
2. Negative 2.
No.
Imaginary. Oh, right, can't be negative.
Can't be.
Yeah.
There's no such thing. It's only root negative 4.
Yeah, you cannot do this. There's no number I can square to get negative 4.
Yeah.
But
Just impossible. Huh?
No, we didn't. Okay.
Okay? So, because of that, mathematically, you can't take the square root of a negative number. What you do is you use an imaginary unit to basically say, hey, you can't really do this mathematically, but let's imagine that you could. This is the result that you get. All right, so what you do is you let I represent the negative part of the root, and then like before, you do the square root of 4. So your answer would be 2I. And the I just kind of reminds you and everybody that, hey, I did something mathematically that I shouldn't do. So we're just going to call this imaginary. Does that make sense?
Yeah.
You have these rules with imaginary numbers where you have like I to the first power, I to the second power, I cubed, I to the fourth. Anybody remember what these equal?
No.
Okay.
Negative 1.
Just I. We can't change it. Whenever you have I to the first power, it's just I. Whenever you have I squared, it results in negative 1. So what I mean by that is, let's say you had like 2I times 3I. 2 times 3 is what? 6.
Oh, 6.
I times I is what?
I questioned myself. Because I say
I squared. Since you have I squared, you can change it to negative 1. And it's multiplication. Negative 6 would be your result. All right, so whenever you have I squared, you can replace it with a negative 1. Whenever you have I cubed, it's really negative 1 times I, because it would be 2 plus 1 more. So we just write that as negative I, because it's negative 1 times the I. Everybody see that? And then if you have I to the fourth power, any guesses?
So it's like negative 2.
Positive 1. Great job. It's really 2 of these. Negative 1 times negative 1, positive 1.
Oh, you want to add.
All right, so these were like the properties of imaginary numbers, or I. Okay, whenever these situations arrive, you can substitute them for that. So we're not going to be like doing a whole bunch with this stuff. Every once in a while, we'll do some where you get like I squared when we start simplifying our answers on another day, not today, on some other day. And you might do this, but we'll come back to this. But in a nutshell, this is imaginary numbers, how they work, why we use them. Everybody feel like they kind of got an idea what we're looking at? All right, so let's go over to our notes that I just had but do not have anymore. All right. So we were working with these rectangular coordinates, an x and a y value, but now we're going to add an imaginary part to it. So what we have is a complex number, where the first part that's a real number is like the real part of it, and the second part, which we use y to represent it, is like the imaginary part. together you have a real and an imaginary part. It makes it complex. We call it a complex number. Consists of two parts. When we go to graph these, we graph them just like we would an x and a y coordinate. The x-axis will represent the real number. The y-axis will represent the imaginary number. So in this case, x would still be x, y would still be y. Together, they get you to some location, which is how we plot these points. I can probably show you this better than I could tell you. Let's graph a couple of the points below. So the first one, 3, -7. Here I'll go right 3. 1, 2, 3. Since it's negative, I'll go down 7. Right 3, down 7.
Okay.
This is where my first point A is. Remember, the real number takes me left to right. The imaginary number,
Up and down.
up and down.
Okay.
Pretty simple, right?
Yeah.
Yeah.
Talk to me about B. Where do I move first?
Right 2, up 3.
Yeah, and that's it. Right 2, up 3.
That sounds fine.
And we just graphed a complex number. Let's give everybody a 10 seconds to think about C. I know some of you already know. You already wrote it. Think about where C will be. Real sends me left to right. Imaginary sends me up or down. How do I get to point C?
Left.
Up to.
Left 2, up.
Left 2, up 2.
Oh, yep, 2.
So why does the
Oh my god.
Being dropped off.
why does the imaginary number like have to be there? Because it would be the same thing if I just plotted -2, +2.
That's a good question. With these imaginary numbers, if we want to convert them, or if we want to like find the magnitude of it, which we'll talk about later, you kind of need to set up like your right triangle. So being able to plot it gives us like a visual representation to like figure out the other pieces of it. So like in a second, we're going to convert these to polar form. Just like with rectangular coordinates, like we didn't do now, you'll graph it, you'll find the hypotenuse, and then that'll give you your R, and then you'll set up your ratio to find the angle. So like, it just makes our life easier if we can have a visual representation of where this point is.
So the I isn't really like it doesn't really matter like, when graphing, but once you get into like the more complex stuff, it does matter.
It does matter when you get to other maths, and also when you talk about like the magnitude, because this will be like a vector, which a vector is like
It's complex. It's calculus.
not the basics of it. I mean, a vector is just like this line could be a vector.
Yeah.
From this point to this point. It's almost like a ray in geometry. From O to this point could be a vector. A complex number could be represented by a vector. I mean, you go right, you go up, but then what you need to know is like the magnitude, how long the vector is, like how big the vector is. So you would use like the relationship of X and Y to find that out.
So are imaginary numbers used in engineering?
Yeah, you use it in engineering. Sometimes like you can get an answer that works, but mathematically like you weren't supposed to do that.
Okay.
So like you might take the square root of -9 and get an answer that works, but like your calculator isn't gonna give you that.
Yeah.
So we use imaginary numbers in those cases. Like if I could, this is what I get. Yeah, it's imaginary, but the visual representation that I needed to use, I was able to use it. Does that make sense?
Yeah.
All right. Okay. So everybody okay plotting these? Forget my little tangent or whatever. Everybody okay plotting these?
Okay. Tangent.
All right. Okay, so the next part we'll do is just convert. We'll start off with complex number in like regular form, which is kind of like an XY value as we see, and we'll convert it to polar. Now if we go over here, it's basically the same setup. The only little change is with the Y coordinate, we have the imaginary part in it because it takes me up or down. So it's the same setup as we did. We'll take the radius, and we need a theta with it. For the y coordinate, it's sine. We need the radius, and we'll find sine of whatever angle we're looking at. We'll just add an I with it, okay? So like when we write it in polar form of a complex number, it'll look like this. And when we get to this part, it's literally what we did before. It's just you write it a little differently because we got this imaginary part with it, all right? So let's start off with the complex number. And like I say, it's complex because we have a real number and we have an imaginary part, all right? This is just like when we convert from a rectangular number, a rectangular coordinate, into a polar coordinate. The steps are even almost identical except for the very last one, how we write it. Okay, so we start it the same way. We're going to plot this point like we just did. How would I move first to plot this point? Right, root 3, and then down. So I'm going to zoom in on this fourth quadrant. I'm going to go right, root 3. Like I say, don't get caught up on how far over you got to go. Just go in the right direction. And then I'll go down 1. I don't see a 1. How did you know to go down 1? Yeah, it's understood to be 1i, negative 1i. So I just go down. Just like before, I'm going to turn it into a right triangle. By going to the x-axis, I'll draw my little angle. And now I got my reference triangle to refer to. So that's step 1. We plotted the point and we kind of set up a little situation. What are we finding to do now next? What do we find first? The C, the hypotenuse. So just like before, you find the hypotenuse of this. A squared plus B squared equals C squared. Or you would use the other form of that. Just the trig form of that, which I'll do. To get R, or the hypotenuse, you do the square root of the two sides. Yep. Root 3 squared is 3. 1 squared is 1. 3 plus 1 is 4. Square root of 4 is 2. So R is 2. So when I get ready to fill this out, just so we can start to match things up. Before it was just R theta. When I go to match this up and I write it in this form, R will go right there. The only other thing I need is to figure out what this angle is. Everybody okay with finding R, the hypotenuse?
Yes.
All right, so let's figure out what this angle is. Anybody got any guesses? What's the x value? Root 3. X is root 3.
Over 2.
root 3.
Cosine is 3 over 2. Fourth quadrant. I know it goes 3, 2, 1. It's a 30 in the fourth quadrant, which is 330. That's my angle. All right, let's do it formally. I like to use cosine. Use whatever function you like. Cosine is which two sides? A over H. What's A?
Root 3.
What's H?
2.
2. Which quadrant am I in?
4.
So I'm looking for an angle in the fourth quadrant where cosine comes out to be 3 over 2. Man, I cannot keep up with that unit circle to save my life. Oh,
Was it your laptop that was making that noise?
I hope not. Fourth quadrant, cosine 3 over 2,
Positive.
right here. Perfect. That happens at
315.
No, 330.
330. My bad. 330. 330. That's my answer.
Yeah.
So I'll say, just a little note for myself when I look back at it. I'll say this maybe this happens at 330 degrees.
Wait, how do we add the I?
So what we're gonna do is, so we started off with this. When we convert the other way, we'll go backwards and finish with this, but we basically say this is the x coordinate, this will be the y coordinate. When you answer it, you write it like this. So I just rewrite this. I replace r with 2, and I replace theta with 330. And that's it.
Dos manos.
Hey, Mr. Shields.
Those, what? Why am I repeating what you say when I don't even?
It means 2 hands.
Yes.
Oh, why did you say that?
I don't know, I forgot what manos meant, and then I was like, oh wait. It's no ciudades.
So I got 2.
It's dos ciudadanos. Take Latin, but it's Spanish.
2
No, that's
cosine 330 plus, don't forget your imaginary unit. It's really annoying when you forget that on Alex.
okay.
I do it when I'm working problems. And then sine of the same angle. And that's my answer.
Oh, you just plug it in, you don't like solve it?
I think, do we solve it later, or do we solve it now? Oh, that's just it?
If you were going backwards, you would solve it.
Okay.
Like I would find cosine of 230, 330. I'd say, oh, that's 3 over 2.
Oh,
And then
yeah.
I multiply by 2, and
Oh, because.
then I would get what I started with. So yeah, you just leave like this. Yep.
Wait, how did you?
So that's the polar form?
How did you get 330 degrees? Like, I'm guessing with like the.
I asked myself.
Oh, no, I see, because that's like, it's supposed to be the 4th quadrant, right?
Yep.
Yeah, and no, I see.
Okay. Any other questions? So the only difference before was you could just say 2, 330, and it was understood that cosine and sine would be at 330. But now since we got this imaginary unit, we just got to separate it because it's not given. All right? All right. And after we do this a few times, I'll show you the shortcut way to write it too. All right, let's do another one. Step 1, what do I do? Right, how do I move? Right 4 down 4. Interesting, these coordinates are the same. What do you think this angle is going to be? 45, 3rd quadrant, 315. So without even doing a whole lot of work, we know the angle. We just got to figure out the hypotenuse, which is r. I'll do r equals what squared?
4 squared.
Plus
Negative 4
-4 squared.
squared.
4 squared is 16. -4 squared is also 16. Can I reduce?
There's actually a spelling
Yes.
for it.
No.
I can't get rid of the radical, but I can reduce it.
It's
Oh,
double
you
by
can take out like
Or maybe like
Wait,
something weird.
32
than that. I think that's weird.
divided by
32 divided by 2 is what? What's the square root of 16?
4.
yeah.
So if I break it down like 16 times 2, I can take the 16 out. The 2 I have to leave though. So r is 4 root 2. And at this point, we said the angle was 315. That's just what you fill in. I'll show how we can check to make sure the angle is what we think it is. But yeah, if you understand that, you're good to go. Okay, so again, I'll look at the ratio for cosine based on what I'm given. And I'll say cosine equals A over H. What's A?
4.
What's H?
4 root.
Can I cancel anything?
Yes, the 4.
Which gives me 1 over root 2. When I rationalize, what do I get?
1 over 2. Oh, yeah.
This happens at a 45. And then you would say, oh, what's the 45 in the 4th quadrant? 315. Those are my 2 pieces I need. Want me to show you the abbreviated way to write these? Instead of writing out cosine 330 plus I sine 330. The abbreviated way is just to write CIS. So, 2 CIS, what was it, 315? Dang it.
Oh, boy.
Two would be our number though, right?
Yeah, 2 is our R.
Wait, what did you just write? What is that?
Oh, I'm sorry, 4 root 2. My bad.
I was really confused.
My bad. I apologize.
Wait, I'm confused. Oh, okay.
I wrote it wrong. So it should be all right, so this is the abbreviated way to write it. Like when you type it in, you'll just fill in the blanks. But you can write it like this. It's cosine plus I sine. Both of these are 315. So your R goes out in front. All right, so basically just like what we've been doing, right?
Yeah.
Just that you answer a little different.
Wait, what is that CIS? Does it stand for cos I sin? Okay.
Like I said that before, so.
Well, I still don't understand because I just keep imagining something else.
Okay. And then just like with polar and rectangular, going the other direction is super easy. All we do is get the exact value and then distribute the R value and we get our answer. Okay? So, to get me started, I need to know what cosine of 210 is. Yep, I go 210. Cosine is the x-coordinate, negative root 3 over 2. Sine will be negative 1/2. So I'll replace those functions with their exact values. I get 3, negative 3 over 2. I'll go ahead and say, actually I'll say plus. I times negative 1/2. I'll distribute the R. I'll simplify and I'm done. So 3 times negative root 3 over 2. And I can't simplify that. And since it's a positive times negative, this whole outcome would be negative. So I'll go ahead and do minus. And then I got 3 times 1 over 2. And then just don't forget this. You need your I in there. And this is a complex number. This is my real part. This is my imaginary part. It's the same thing as you've been doing, except it's not a coordinate, it's a point. It's a complex number, and then you just gotta write this imaginary part to it.
That's it?
That's it. That's it.
Wait, that's the.
No, we have 25.
That's the rectangular form?
Yeah, yep. Of a complex number.
I think we're also having it Thursday or Friday.
All right.
Seniors can get their cabin.
Yeah.
Let's do this last one.
Oh, we have Richmond today?
Yeah, we do. We have enrichment every Wednesday now.
My teacher's up in Let's try to remember. Oh, wait, that's good.
All right, so I need the exact value, cosine of 30. What's that exact value? Root 3 over 2. So I got 3 times root 3 over 2 plus I times sine of 30. Sine's exact value is 1/2.
So it's the same answer but positive?
Yep, the signs are different. So this would be 3 root 3 over 2 plus 3 over 2I. That's it. If these numbers cancel, like with the other ones, you could, if this was 4 over 2, you would cancel them and you get something else. All right, so this is what we started with when we did these problems up here. And this is what we finished with.
Okay.
All right, you guys have any questions?
No, sir.
Okay, so this won't be on your quiz. This won't be on your quiz. just the other stuff we was doing like last week, and yeah, last week, we didn't even do anything this week. All right, if no questions, you got some practice problems you can be working